In this video, we will cover the second half of the Unit 1 test review, which will be simplifying radicals. For each of these radicals, we're going to start off by building a factor tree. So 175 is divisible by 5 and 35, so we're going to start there. Remember to circle your primes. 35 is 7 times 5. So this becomes 7 times 5 times 5. Group of 5s means we can pull one out. And our answer is 5 square roots of 7. Number 15. We can break this down as 16 and 8. 8 is 4 times 2. 4 is 2 times 2. 16 is 4 and 4. Each of those 4s breaks down as 2 times 2. A lot of 2's here, so let's make sure we count them and get them all there. 1, 2, 3, 4, 5, 6, 7 2's. So 1, 2, 3, 4, 5, 6, and 7. Pair them up. That guy's all by himself, so we've got 1 2, a second 2, and a third 2 all outside. Multiply those together. 2 times 2 times 2 gives you 8, with 1 2 left over. Moving on down to 16. 216. Let's start simple. Start with dividing it by 2. That gives us 2 and 108. 108 is 2 and 54. 54 is 2 and 27. 27 is 3 and 9. 9 is 3 and 3. Okay. As you're building these factor trees, if you're not sure where to start simple. Start dividing the number by 2 and see what you get. So here we've got 3 2's and 3 3's. So we've got a pair of 2's, a pair of 3's, and then we got a couple numbers left there by themselves. So I'm going to bring a 2 out, and I'm going to bring a 3 out, which gives me 6 outside, and then 2 times 3 also gives me 6 inside. Lastly, number 17. 16 breaks down as 4 and 4, which will both break down as 2 and 2. Now you're going to notice when we group up here, we have nothing left over. So when we pull these guys out, we have nothing left underneath the square root. When that happens, you don't need the square root. So in this case, our answer is simply 4. Move on and look at a couple examples with variables. 448, start simple, start with 2. 2 again gives us 2 and 112. 2 again gives us 2 and 56. 56 is 7 and 8. 8 is 4 and 2. 4 is 2 and 2. So we've got 1, 2, 3, 4, 5, 6 2's and a 7. So when we write that out, we've got 1, 2, 3, 4, 5, and 6 2's and my 7, and then I've got x to the third. So I've got 3 x's. Let's pair them up. 7's by itself, and that last x is by itself. So I can bring out 1, 2, 3 2's, and I could bring out an x, and I still have a 7 and an x left over inside. Multiplying what I have outside together gives me 8x square root of 7x. Number 19, 392. We'll start simple again. Divide it by 2 leaves us with 2 and 196. 196 divided by 2 gives us 2 and 98. That gives us 2 and 49. 49 is 7 and 7. Okay, so we're going to write this out. We've got separate, a lot of stuff going on here. Okay, So change colors here. I've got the square root of 2 times 2 times 2 times 7 times 7. And then I have 5 n's. So 1, 2, 3, 4, and 5. Let's look for our groups. Here, 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 and here. Got a 2 left over and an n left over. So outside I get to have a 2, a 7, and then 2 n's. So rather than n times n, I'm going to write n squared. Inside I still have a 2 and an n left. Multiplying that together gives me 14n squared, square root of 2n. Move down to number 20. 80 simplifies to 8 and 10. That gives me 4 and 2. And that's 2 and 2. 10 is 5 times 2. So now I've got the square root, 4 2's, a 5, and then I've got a solitary x. I group these together. 5 doesn't have a pair, nor does the x, so those guys are going to stay inside. I can bring out 1 2 from the first pair, a second 2 from the second pair, and then I've got 5x left inside. Multiplying the 2's together gives me 4 times the square root of 5x. Number 21, 32 breaks down as 2 and 16. 16 is 4 and 4. Both of those break down as 2 and 2. So I've got 5 2's and 4 a's. So grouping these up, pair, 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 and a pair. All I have left is a solitary 2. So I've got 2 and 2 for my groups, and then I've got a and a, so I'm going to write a squared. Multiply my 2's together, and I get 4a squared, square root of 2. Down to 22 here. 48 is 2 and 24. 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So I have 1, 2, 3, 4 2's, a 3, 1x, and then 4 y's. 1, 2, 3, 4. Group, 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 and group. These guys are left by themselves. So I can pull a 2 and a second 2, and then I can pull out 2 y's. So once again, I'm going to write y squared. Inside I still have 3x. Multiplying gives me 4y squared, square root of 3x. Lastly, in 23, 112 breaks down as 2 and 56. 56 breaks down as 7 and 8. 8 breaks down as 2 and 4. 4 breaks down as 2 and 2. So I've got 4 2's and a 7. And then I've got 4 x's and 3 y's. Group, 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 group. Y left by itself, 7 left by itself. So I've got 2 2's, 2 x's, and a single y with a 7 and a y left over inside. Multiplying together gives me 4 x squared y, square root of 7y. Finish up with some cubed roots. Remember, with the cubed roots, we're looking for groups of 3, no longer pairs. So 750 breaks down as 10 and 75. 10 is 2 and 5. 75 is 3 and 25. 25 is 5 and 5. So here we've got the square root of 2 times 3 times 5 times 5 and times 5. I've got my group of 3. Same rules as square roots. A group brings 1 outside. That means I've got 5. Multiply the 2 and the 3 back together to give me the Sorry, don't forget my cube. Cube root of 6. All right, 25, 1,000 breaks down as 10 and 100. That's 2 and 5. 100 is 10 and 10. Once again, 2 and 5. Don't forget to circle your primes. So I've got the cubed root of 2 times 2 times 2 times 5 times 5 times 5. Groups of 3 here and here. Notice that I have nothing left over, so just like we did with the square root of 16 back at the beginning, I have nothing left over, so I don't need the cubed root anymore. I can bring out a 2, I can bring out a 5, so my answer becomes 10. 26, 40 is 4 and 10. 4 is 2 times 2. 10 is 2 times 5. So I have the cubed root of 2 times 2 times 2 times 5. Group of 3, pull a 2 out. 5's left by itself. Gives me 2 cubed roots of 5. All right, 27, 384. It's a big number, so we're going to start by dividing by 2. 2 and 192. Dividing that by 2 gives me 2 and 96. We're going to keep going with this pattern. That gives me 2 and 48. Dividing by 2 again gives me 2 and 24. 24 gives me 2 and 12. 12 gives me 2 and 6. Running out of room. 6 gives me 2 and 3, and I'm finally done. A lot of 2's here, so let's count. Make sure we've got them all present. 1, 2, 3, 4, 5, 6, 7 2's. So we've got the cubed root of 2 times 2 times 2 times 2 times 2 times 2 times 2. I think that's all of them. 1, 2, 3, 4, 5, 6, 7 2's, and a 3. Looking for groups of 3, group of 3, group of 3. Nothing I can do with those two. Each of these groups I can pull out a 2 from the first, pull out a 2 from the second, multiply the 3 and the 2 back together to get 6, multiply the guys outside together to get 4. My final answer is 4 cubed roots of 6.